Hey guys, welcome back to my channel. This is Varun Tahin. So we have seen some of the rules of probability with the use cases for each one of them in the last session. And now we will see some other ways of calculating the probabilities based on the scenarios and inputs we have. So today we will be looking into the concepts of permutation and combinations and problem associated with each. We will also see the concepts of random variables and expected values in the context of distributions by taking elaborated examples. Now let's say that we wish to find ways of arranging n distinct objects into an ordered sequence. Now in these kind of problems, the normal probability rules which we discussed are of no use as it involves the logical understanding of how shuffling and arranging works. Okay, so we will understand this with the help of example. Okay, let's say that we have two different color balls. One is red and the other one is blue. Okay, so guys, how many different ways we can think of arranging them in sequence? Exactly. So there are only two different ways, which is first red and then blue, and then first blue and then red. Okay, so exactly two ways of doing this. Now what if we increase the number of balls, and now we have three balls, that is first red, blue and then green. So now we can arrange them like this. So as per the combinations, there are 6 different sequences that we found. And looking at these examples, we can find a pattern here. And it appears that it is n factorial. So guys, if you are familiar with the mathematics concepts of factorial, it refers to the product of the numbers starting from 1 till the n. So it is something like, now here n refers to the number of balls. Okay, so you can fit this equation here in this scenario. So the number of balls here is 3. So 3 factorial is 1 into 2 into 3, which is 6. And here the number of balls are 2, and therefore 2 factorial is 1 into 2, which is 2. Now there are several other definitions which we like you to remember. The first we have already seen, which is factorial, which says, so there are n factorial ways of arranging n distinct objects into an ordered sequence. So this elaborates that if we have n distinct objects, we have n factorial ways of arranging them differently. And this is equivalent to permutation when n is equals to r. We will see this statement in a short while. Now combination refers to the number of ways to choose a sample of r elements from a set of n distinct objects where order does not matter and replacements are not allowed. So that means that we will apply combination when a problem says to choose a sample of r elements or a sample of smaller elements from a set of larger objects or larger samples, and the problem clearly says that the order does not matter and replacements are not allowed. So out of n different objects, we are choosing r samples and we calculate combinations via this formula, which is n factorial divided by r factorial into n minus r factorial. Now with the small change of ordering, let's say the order matters in that particular question which we had previously. Okay, in that case we will use permutation and there will be a small change in the equation as well, and we will not use r factorial. So the equation becomes n factorial divided by n minus r factorial. And let's say that the value for r is equal to n, that is we are using the first scenario where we are choosing all the numbers or all the objects. So in that case this n minus r will become 0, and so 0 factorial will become 1, and therefore this will become n factorial. Now we are left with two other scenarios where we choose a sample of r elements from a set of n elements, and when the question says that order does not matter but replacements are allowed. So in that case this equation will be used, which is n plus r minus 1 factorial divided by r factorial into n minus 1 factorial. So this is just a simple modification to combination with replacements. And there is then a second variant for permutation also. So permutation says that the replacements were not allowed, but in this case the replacements are allowed here. So in this case permutation replacements equation, which is n raised to power r, will be used. Now this page will give you a gist of whatever we have discussed, so you can note this down and keep it ready for further questions. Now we'll look at one of the problems of combinations. Okay, so combinations is basically used when n is greater than equals to r and r is greater than or equals to 0, and it is also referred as r combination n choose r or binomial coefficient. Now we'll see where this equation will be applied. So let's say that I won first position in a competition and I'm allowed to choose 2 prizes from 6 prizes. So how many different combinations I can apply to choose those 2 prizes? So here we can apply combinations. The reason is the order does not matter here because we can choose any price, and also replacements are not allowed because we are allowed to keep the 2 prizes. So we will not replace the first prize when we are choosing the second prize. Okay, so we'll apply combination. So here n is equals to 6 because total 6 prizes, and from that we are allowed to choose 2. So r becomes 2. So the equation becomes 6 factorial divided by 2 factorial into 6 minus 2 factorial, which is again 6 into 5 into 4 factorial, and we'll expand this. So 4 factorial. So this cancels out and the answer is 5 into 3, which is 15 combinations. Now we'll see a problem for permutation as well. So a code has 4 digits in a specific order and the digits are between 0 and 9. How many different permutations are there if one digit may only be used once? So this statement that one digit may only be used once signify that the replacements are not allowed, and this problem clearly says that it is in specific order, so the order matters here. So permutation exactly fits here. So we'll apply permutations here. So n becomes 10 because 0 to 9 total 10 numbers are there, and from that we are choosing 4 digits, so r will become 4. So the equation here becomes 10 factorial divided by 10 minus 4 factorial. So this becomes 10 factorial divided by 6 factorial, which will be 10 into 9 into 8 into 7 into 6 factorial, and here 6 factorial will be cancelled out. So further it will be 90 into 8 into 7, which will again be 720 into 7, which is 5040. Now we'll try and solve a question using ball example and understand the other terminologies and concepts of random variable, distribution and expected values. So let's say that we have 5 ball game problem in which we have 3 balls as red and 2 balls as blue, and we have to draw 4 balls, one each time with replacement. So this game is played by many users, and what we have to do is we have to calculate the profit or loss per player based on the number of red balls drawn. Okay, so we will try and approach this problem like this. So first we will find the possible combinations, then find the probability of each of the combination, and then use those probabilities to estimate the profit and loss per player based on the number of red balls drawn. So we'll start by finding the possible combinations for it. Okay, so what can be the possible arrangements? We can either have 4 blue balls and 0 red ball, then we can have 3 blue balls and 1 red ball, we can have 2 red balls and 2 blue balls, and there can be 1 blue ball and 3 red balls, and 0 blue balls and all 4 as red balls. So this is summing up to 4 balls in total. So we are choosing 4 balls, and out of that we are having these possible combinations. Now we will try and see the number of combinations which can be formed in each of the categories. So there can be only one possible way here, that is this. All 4 balls are blue. Then for 3 blue balls and 1 red ball, there can be numerous combinations. So there can be blue, 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 and then red. Now likewise for the others also we can make the pairs. So you can possibly make out the number of combination in each of these categories now. So here it is 1, here there are 4, here there are 6, here again there are 4, and here it is 1. So now that we have find the possible combinations, the second step is find the probability of each of the combinations. So before going to that step, we will understand the concept of random variable first. So the random variable quantifies the outcome of the random occurrence of our interest. So let's say in this case x, which is number of red balls. Now let me take some examples and show it to you what it exactly means. Okay, let's say that I have 1 blue and 3 red balls. So here x is equals to 3 because we are taking x as the number of red balls and the number of occurrence in this scenario is 3. So x will be 3. Similarly, if 2 blue balls are there and 2 red balls are there, then x will become equals to 2. So this will be our random variable which is of our interest. So now that we have seen what random variable means, Let's now see the distribution by allotting some balls picked by all the 75 players and jot them down in the frequency of their occurrence in this histogram. So what we have done is, in this histogram we have numerically scaled the x-axis with the number of red balls, and on y-axis we have mentioned its frequency of occurrences by all the 75 players. So the another way to look at this is that 2 players have got 0 red balls and 4 blue balls. Then 12 players have got 1 red ball and 3 blue balls. 26 players have got 2 red balls and 2 blue balls, and likewise. So as per the second step, now what we need to do is we need to find the probability of each of the combinations. Okay, so this is for 75 players, and then we need to find out the probability for each of the player. So for that, what we'll do is we'll just divide the frequency by the number of players in total who played this game. So let's do that. Okay, so for 0 the frequency was 2, so 2 divided by 75. Then for x is equals to 1, there were 12 players who have got 1 as their red ball, so I'll just say 12 divided by 75, and likewise I will just dot these down. So guys, what is the purpose of creating this probability table is, right now what we have is only small number of players, that is 75 players playing this game. Now let's say that we have 1000 players playing with us, and we have to estimate the number of players picking only one red ball. So what we will do is, basis on our probability, we'll just multiply the probability for picking one red ball by 1000 to get number of players picking one red ball. So this is the exact reason why we do sampling also, to calculate the probabilities for the larger population, which is the sole purpose of inferential statistics. So as we said, if number of players are 1000, then the number of players with one red ball would be 0.16 into 1000, which is 160. So likewise for each one of these we can calculate it. So this will be 27 and 160, 347, 333 and 133. Okay, so if these are the numbers and if 1000 people are playing, what is the total number of red balls you can expect them to take out? So for this, what we'll do is we will multiply this value with the frequency of their occurrences. So this becomes 0, because if 27 is multiplied by 0, it will be 0, and for the others we will just mention it here. So now that we have calculated the total number of red balls, what we can do is we can also find out the average number of red balls drawn by one person. And for that, we just need to divide this by number of people who played this game, which is 1000. So this is 2.385 red balls per person. Now why we did this? Because we need to calculate the expected value, which is our final aim. Okay, remember guys that the step 3 said that use the probabilities to estimate the profit loss per player. So that profit and loss is the expected value here, because profit in this case is gaining more red balls. Okay, so the expected value by definition means that it is an anticipated value for an investment at some point in the future. So our investment is based upon the red balls count, and the expected value is calculated as such. So it will be calculated by multiplying each of the possible outcomes by the likelihood each outcome will occur, and then summing all of those values. So it will be something like x1 into probability of x is equals to x1, then plus x2 into probability of x is equals to x2, plus, and then going this to xn into probability of x is equals to xn. So now that we know the expected value formula, we'll substitute the values for corresponding x and their respective value for the probability of x. So the equations become 0 into probability of x of 0 plus 1 into probability of x of 1 plus 2 into probability of x of 2 plus 3 into probability of x of 3 plus 3 into probability of x of 4. So now we'll substitute the various probabilities. Now you'll observe that we have taken into account all the probabilities and all the values of x in this calculation of expected value. Now what we'll do is we'll assign the random variable x to the money won after playing the game once, and then we will see what is the expected value and is it beneficial for the player to play the game or not. Now what we are doing is, as planned, we need to calculate on an average player how much each person is winning, or if this game is a beneficial for player or the house. So for that, I've made X as a random variable which says money won after playing the game once, and ideally it should take these reward points, that is 150 when the player draws 4 red balls, that is this case, and -10 when even one ball is not red. So for simplicity, so that you guys are not confused, I have made X as the random variable with the reward points, or you can consider them as rupees, and for the number of balls drawn, I have kept that as variable Y. Okay. So what we have to do is we have to calculate the probability of getting 150 rupees, that is in short probability of getting 4 red balls. So this is clearly this thing, so we'll just mention it here. And we need to calculate probability of getting -10 as reward points. So this says that when even one ball is not red, which is rest of the cases. So we will substitute these values over here. So 0.027. Okay. And now what we have to do is we need to calculate the expected value. So as we have seen earlier, that it is nothing but just the summation of product of X and their probabilities. So we'll consider X as 150, and then the probability for X as 150 is 0.133 plus -10 into 0.867. So this comes to 11.28, which is in positive. So what this positive value indicate here for this expected value, that the game is a disaster for the house, and on an average a player will win 11.28 rupees and a penalty is only -10. So if a lot of players play this game, we will end up losing a lot of money. So if we want to make profit, or if the house wants to make a profit, then either decrease the prize money or increase the penalty. So this will make the expected prize won on an average by player in negative. Now let's say that we want the house to win. So in order for house to win, we need to change either of the conditions of either increasing the penalty or decreasing the prize amount. So let's say that we are increasing the penalty to 25, and let's check with this what value we'll get, and then decrease the price to 90 and check with this too. So in the first condition, it will be P X equals to 150, and we'll calculate this as 0.133 into 150, which is 19.95, and P X equals to -25, which will be 0.867 into -25, which is 21.675. So this sums up, we need to add this. So this sums comes up to -1.725, and let's check this value also. So P X is equals to 90 and P X is equals to -10. So for this case, 0.133 again into 90 equals to 11.97, and this is 0.867 into -10, which is -8.67, and this sum comes up to 3.3. So you can clearly see that increasing the penalty to 25 makes the difference, and that is the reason we are seeing minus in the expected value. So this approach works for us, but this does not help much in the case of house winning. So this sums up the expected values and random variable introduction to you guys. Let me know if this session helped you in covering the scenarios you were looking for. If you liked it, please don't forget to give it a thumbs up, and if you are new to this channel, please don't forget to subscribe and hit the bell icon for future updates. I will be comprehensively covering more statistical concepts and example in my upcoming sessions as well. So stay tuned. Thank you for your continuous love and support to this channel. I will see you guys in the next session. Until then, take care and happy learning.